This is problem number 1.4. F of a dagger, is a function which can be expanded in a power series of a and a dagger, then show that the commutation of a annihilation operator and this function is equal to partial f divided by partial a dagger, and the second part is a dagger and this function is equal to partial f divided by partial a, and the e की power minus alpha a dagger a and this function and this is equal to f of a e की power alpha comma a e की power minus alpha. To start this problem, we must consider this function is a linear. This is expanded in a power series. If we expand this is a power series of a and a dagger, then we must consider this expression, this function like summation of rs, f rs, r as any numbers, so we can r and s. So A or A dagger S. Let consider this commutation relation, and this commutation relation we can write the function in this form, and further we can take out this and this term, and we have a R and a dagger S. And further, by taking the rule of commutation relation, first we consider this in the left side, and we have a commutation of this, and then plus we can take a dagger S at the right hand side, and we have commutation of A and AR. So I have written this and this. It should be noted that the commutation of any two by the commutation of any operator by itself, which is equal to 0. So this term, if we give the value of r which is equal to 1, so it means that a and m which is equal to 0. And if we consider the value of r is equal to 2, then we can expand this by this rule, and then we must have the value is equal to 0 of this commutation relation. So this term is equal to 0 and we have only this term. So I have written this term. Now this is important to know that I have written the commutation of this a dagger S. The commutation of this I have written in this form S a dagger S minus 1. Now this is true because if we consider S is equal to 1, then it means that a dagger S is equal to 1, then S is equal to 1 here, and a dagger and 1 minus 1. So it means that the power is equal to 0, and we have anything which has power 0 which is equal to 1. So 1 into 1 which is equal to 1. So a dagger is equal to 1. So this is true because the commutation of a and a dagger, this always be equal to 1, and we have proved already this thing. So it means that this expression is true. And further, if we look to this function, this is important. If we differentiate this function with respect to a dagger, then what will we can get? Let's see. Partial f divided by partial a dagger. If we differentiate this with a dagger, then these things remain the same. Rs, Frs, AR, and differentiate this with respect to s, then we have s and a dagger s minus 1 by the rule we have. So it means that this term, this is nothing but this is the differentiation with respect to a dagger. So partial f divided by partial a dagger, this we can get this. So it means that the commutation of a and this function, which is equal to partial f divided by partial a dagger, and similarly which is equal to a dagger and this thing. So the first part and the second part, there is no, in the calculation there is no any change, but instead we can consider a dagger instead of a. Here the function is partial f divided by partial a dagger, and here the function must be partial f divided by partial a. So try to do this, to prove this by yourself using the same process. The third part is e to the power minus alpha a dagger a f of a dagger e to the power alpha a dagger a. So we must show this, the left hand side, which is equal to f of a e to the power alpha a e to the power minus alpha. So first consider the left hand side, e to the power minus alpha a dagger a f of a dagger e to the power alpha a dagger a, and let putting the value of f of a and a dagger. So we have e to the power minus alpha a dagger a, and the value of this we already know is the summation rs f of rs and a r and a dagger s. So this is actually previously we have considered, and a dagger and a. Now we can take this summation of this and e to the power minus alpha a dagger a, and we have this rs and e to the power alpha a dagger and a. And using the relation that we already know about this relation, we must apply e to the power alpha a b e to the power minus alpha a. This is equal to b plus alpha a b plus alpha square divided by 2 factorial a b and so on. So this and this relation, this remains the same, but only we have a dagger a, which is equal to a, and ar and a dagger s, this is b. So following the same formula this, and we can expand this, like for example this is equal to summation rs f rs, and here b, what is b? B is ar a dagger s, this is b, and plus alpha. So we have minus here, so we can take this minus because this is minus and here this is plus. So we can take this minus and here a b. So a is this thing, a dagger a, and b is a r, a dagger s. And then minus alpha square divided by 2 pictorial, and we have a b. So it means that a is equal to a dagger a and a dagger a and a r, a dagger s. And for rs, if rs, and this expression can be obtained by considering e की power minus alpha a dagger a and a r e की power alpha a dagger a and multiplication with e की power minus alpha a dagger a dagger s e की power alpha a dagger s. So it means that if we multiply these two terms, this term and this term, we can get this term. And finally, this is a function. This is a function of a and a dagger. It means that this is a function of a e की power alpha and a dagger e की power minus alpha. So